Hey, welcome back. This section is 9.6, Dilations. And some vocabulary for this chapter or this section is, of course, dilation. We have center of dilation, the scale factor of a dilation, and what are enlargement and a reduction dilations. All right, let's look at a key concept, dilation. And a dilation is going to be a transformation that results in either an enlargement or a reduction of the original image, and in such a way that it follows a couple of conditions. Before we look at those conditions, let's look at a couple of definition terms. We've got a dilation with a center of dilation C. So if we look at our picture right here, this point right here is our center of dilation. And then a scale factor. Scale factor is greater than 0. And so our notation is a dilation. Then in parentheses we put the scale factor and the center of rotation. And those properties we were talking about for a dilation, the first property is that an image of the center of dilation is itself. So here's a center of dilation. The image of this point is going to be itself. The next property is that for any other point, for example point R, the image R is going to be on the line C, center of dilation, through R and continue in a straight line. And so the image is going to be on this line. Likewise, the image of Q prime, is going to be on the line from C to Q, and we extend that forward. And same with P prime. So any point, its image is going to be on a straight line with its pre-image and the center of dilation. And the last thing we need to remember is that dilations preserve angle measures. So angle R is going to be the same measure as angle R prime. P and P prime, Q and Q prime are going to also be the same. So we've talked about center of dilation and a dilation itself. Let's look at scale factor. A scale factor is, in this example here, scale factor is N. Scale factor is going to be a ratio of the length of the image to the corresponding length in the pre-image. And that occurs with the image length always in the numerator. That's the top of the fraction. So we can look at this. This is right here is referring to our example up here. And so our scale factor, N, is equal to the length from C to the image divided by the center of dilation to the pre-image. So if we look over here, this length, C to C prime, is going to be divided by C to R. And so this one right here, this is our pre-image, this is our image, and as you can see, this is an enlargement. The scale factor is bigger than 1, then it's an enlargement. If the dilation is a reduction, the scale factor will be less than 1. Not negative, but between 0 and 1. So let's look at a couple of these examples. In the example on the left, it says our center is A, so here's point A, and this is going to be an enlargement, scale factor of 2. So if we take this length A, we continue it through B, and continue it farther, and we can do that through all the points. Even this point right here, if we went through A, through C, it would line up there. So then to get a scale factor of each equal to 2, that means the length from the center of dilation to the image has to be twice as big as the length from the center of dilation to our pre-image point. So if this length was 1, then this length would be 2. Or otherwise, if this length was 2, then this length is going to be 4. And if we were to look at the image, all of the dimensions of the image are twice the dimensions of the pre-image. And that again is the scale factor. Now let's look at a reduction. In this situation over here on the right, this time we're using center is C. So again, we do a line from point C, and it's going to go through our image point G. This time our scale factor is 1/4. So now the distance from our image, or excuse me, our center of dilation to our image is not going to be twice as big or even 4 times as big. It's going to be 1/4. So this distance from C to G, if we divide it into 4, that's going to give us the length to G prime. Likewise, if we extend all of our lines from our center of dilation through our image points and take each of those dimensions and multiply by the scale factor, which is 1/4, we will get our image of G prime, H prime, E prime, F prime. And every dimension on this inside, looks like a trapezoid, is going to be 1/4 of the original dimension lengths. So just a quick recap. If we have an enlargement, then our scale factor is going to be greater than 1, and our image points will be beyond our pre-image. If we have a scale factor that is less than 1, but greater than 0, then it will be a reduction, and this time our image points are inside of our center of dilation and our pre-image. Let's go ahead and look at an example problem and take particular note of the notation that we're using. So this time we have a dilation, capital D for dilation. In parentheses we state the scale factor and the center of dilation. Then we indicate what we are dilating. And the question is asking whether this figure is going to be an enlargement or a reduction, and then also what is the scale factor. Let's start by examining this triangle. We're dilating triangle XTR. So if we look for triangle XTR, oh, that's going to be this small triangle. And then our image is going to be X prime, T prime, R prime. So that's going to be the larger figure. So right away we know it's going to be an enlargement. Therefore, this particular multiple choice problem, we can go ahead and get rid of the two answers that are reductions. And now let's look to see what kind of a reduction it's going to be. And here's a place where we can easily make a mistake. To check the scale factor, we need to go the length of xt, our image. That's going to go on the top. So xt is going to be this length 4 and this length 8. So 4 plus 8 is 12, divided by the center of dilation to our pre-image, divided by 4. So it's 12 over 4, and that's going to be equal to 3. So therefore our scale factor is equal to 3. Now here's a common mistake for this type of problem. Many times when somebody looks at this problem, they see the measurements 8 and 4 and want to set up the ratio as 8 over 4, which is going to equal to 2. And so they might come up with a scale factor of 2. Now this is not correct, because if you remember, we need to set up the ratio of our center of dilation to our image point divided by the center of dilation to our pre-image. So center of dilation to our image point is the entire length, where we have 8 and 4. So again, that's where the 12 comes from. And then from x to t is 4. So this is a common mistake, and we need to avoid that. And so last but not least, we can state that our correct answer is going to be B. It is an enlargement with a scale factor equal to 3. Alright, here's another example on the coordinate plane. And most of the time when we do a enlargement or a dilation or a reduction in the coordinate plane, we are going to use the origin as our center of dilation. So that's our origin. So again, in this problem, we're looking at a dilation of quadrilateral JKLM, and we want to know if it is going to be an enlargement or a reduction. In other words, is J prime, K prime, L prime, M prime going to be an enlargement or reduction? And also, what is the scale factor of the dilation? We are told that our center of dilation is the origin. That's what it tells us right here. And so all we need to do is draw a line from our center of dilation through each of our vertices and extend it in a straight line. Now a couple of these are done for you because we can use the axes. Looking at the x-axis, center of dilation to our preimage, and our y-axis, center of dilation to our preimage of J. Now if we want to do the other ones, point M and point L, we could draw those lines in. So here I've drawn in lines from our center of dilation to our preimage for L, and center of dilation to our preimage of M. And so JKLM is our preimage, and our image is the J prime, K prime, L prime, M prime. So we can see right away that this is going to be a reduction. And now we just have to figure out the scale factor. So to figure out our scale factor, we need to look at the distance from our center of dilation to one of our image points and divide that by the distance of our center of dilation to our preimage. Now something like this might be a little hard to calculate. We'd have to use distance formula. We could do it. However, we could use any point in its image that we like. So, for example, if we looked at this distance, 1, 2, 3. So we're looking for a scale factor n is going to be the distance from our center of dilation to the image, so O to K prime. That's going to be divided the distance from O to our original or pre-image, OK. And that is going to be equal to 3 divided by 6. This distance is 3 divided by 6, and 3 divided by 6 is equal to 1/2.